Hello friends, for today's session we are going to check for a second type of pointer, that is nothing but a dangling pointer. So what is meant by dangling pointer? So dangling pointer is a pointer which is points to a memory location which is deallocated or which is not a valid. That means suppose if you have one pointer initially and that pointer is currently pointing to some memory addresses. So suppose this 4 byte of memory address is pointing by this pointer. But after some time, suppose I free out this memory. If I free this memory, in that case your pointer is still pointing to the deallocated memory. So that time this pointer P become a dangling pointer. Now, what was the issue if your pointer is pointing to such a deallocated memory? You may result into the segmentation fault, or we can say the memory leak will be possible, or you will get some unpredictable behavior. We understood that dangling pointer is nothing but a pointer which is pointing to the deallocated memory. And second, the issue may raise with the help of this dangling pointer, maybe a segmentation fault or unpredictable behavior of your program. So now, when this such a dangling pointer will be created, or when such a dangling pointer will be created in your programs. So there is a one scenario when you are going to deallocate the memory with the help of free. So let us check with the help of example. So I have declared one pointer, that is integer pointer PTR, and which is going to allocate the memory with the help of malloc. So now understood that there is 4 byte of memory is allocated with this pointer PTR. So now after some time, if I done some calculation with the help of this PTR, and if I try to go for freeing this memory, that is I will go for free PTR, then what happened? Okay, so here we already allocated the 4 byte of memory and that memory will be pointed by the PTR. After some time, when I go for free the PTR, in that case, whatever the 4 byte of memory is allocated, that memory become deallocated. But still your pointer is pointing to deallocated memory. So in that case, your pointer become dangling pointer. So now your pointer become dangling pointer. So now, what was the solution to use this pointer? That means if I try to use such a dangling pointer, we don't know at which location it is pointing. It may be pointing to our OS memory addresses, or it may be pointing to some other program memory location. So in that case, if you try to use this PTR as it is, you may face the segmentation fault or you may reach to the unpredictable behavior. So what was the solution? You can either go for assigning this PTR with null value. It is fine. So that means this PTR is not holding any valid addresses. Right? That means this was a solution, we can say. If you are go for deallocating the memory and if you are using the free PTR, it is better to reinitialize that PTR for the further usage, because dereferencing of this dangling pointer may result into the segmentation fault or unpredictable behavior. Now we will check for second scenario when your dangling pointer will be created. So second scenario will be like when your variable goes out of scope. In that case, your dangling pointer may be created. Let us check with the help of example. So here I have declared integer pointer PTR. I have created one inner block. So in that inner block, I have declared one integer variable number and I assign the pointer with address of number. So now when I come out of this inner block, at that time whatever the variable declared inside this inner block, that means for current scenario it is a number, is deallocated. So whatever the memory which is allocated for this variable is deallocated when we come out of this inner block. And at that time, if your PTR is pointing to such a variable whose memory is deallocated, then your PTR become a dangling pointer. So that was the second scenario when your pointer become a dangling. That means if your variable goes out of the scope and your PTR is still pointing to such a variable whose memory is already deleted, then we can say that pointer become dangling pointer.
Let us check third scenario when dangling pointer is created. So when we call the function, at that time maybe a dangling pointer is created. So let us check with the help of example. Here I have declared integer pointer p and it will hold the return value of function. And after that I am just trying to print the value of pointer p. Now I declare a function and inside that function I will declare a variable integer y and this y will hold a value 10 and I will just return the address of y from this function. Now we will check the output. So here you will get the warning that is function return address of local variable. What it means? So here if you observe, this y is local to this function. When I go for this return address of y and that return address of y we are expecting it should become here. Now you can understand that pointer p is trying to hold a data of deallocated memory. So that's why you will not get the output in this scenario. So what was the solution? How to avoid this pointer p as a dangling pointer for this code? For that, you can make this y as a static variable because we know that static data is stored into the global memory. So if I make this y as a static and if I run this code, at that time I will get the answer as a 10. So you can check, we will get the answer as a 10. So here we have understood that when the dangling pointer is created and how to avoid that. So around 3 scenarios we have discussed while deallocating the memory. Second, when your variable goes out of the scope. And third, when we call the function. So while writing a code, keep in mind all these 3 scenarios and try to avoid getting a dangling pointer. Hope so you like this video. If you still not subscribed my channel, please subscribe my channel for more videos. Thank you.